as well as the static and sticky. Okay, these are the three different modes of the port security, and they have three different type of actions: restrict, protect, and the shutdown. So you need to know pretty well what are the functionalities for each of the mode that I show from here. Okay. So in this case, for the next one, we go into, you'll be on the MAC address flapping. Okay, MAC address flapping. Because you still remember that for the MAC address aging is about 300 seconds. Okay, for the MAC address aging, it will be 300 seconds. So let's say within these 300 seconds, you are moving from one to the others, or there's someone use your MAC address, spoof your MAC address, and use on the other side. So in this case, you might having the two same MAC address. Okay, but in this case, when you have two same MAC address, the traffic in between, they might causing some of the loop in this case when they have MAC address flap. It means that they will learn from a different interface. So let's have a look for this MAC address flapping. How this causing the MAC address flap? Okay, when MAC address flap occur, it because of MAC address is learned by two interface in the same VLAN, and the MAC address entry learned later override the earlier one. So always they will just overwriting when they learn the first one. In these examples, only when they are not running spanning tree. Okay, spanning tree disable. When spanning tree disable happen, the traffic they will just going to send like this both way. So in this case, switch C, first you will learn from port 1, then later part you learn from port 2. Then third, again, port 1, port 2, port 1, port 2. They're going to flap in between these two ports. Every time they will start to receive the frame. Okay, that is on the drawback of how they're going to be perform the MAC address flapping. Okay, only when there's that spanning tree, it are disabled. That will be happen, and when this happen, a loop will be happening already. So only when the loop, only loops occur, then you have a MAC flapping. Okay, you always have this problem. When you have a looping, then you have a MAC address flap. So in this case, what they perform the flap, because when I send a traffic going through, let's say this is my destination. Yeah, this is my destination. This is a PCA, this is a PCB. Okay, so the traffic, the traffic from here, you can see that what happened. The traffic from here, you'll be going to this way. First, you'll be going to this way, as well as they're going to this way as well. When they are sending the ARP, it's a broadcast packet. When broadcast packet, I will send from switch A to switch C, and from switch B direct to switch C. So in this case, under the switch C routing tables, they're going to be learn from port number 1. When the port number 2 you learn again, this one will be removed. I will learn this. And then the next packet, you will also come from the port number 1. Again, this one will be removed, and this will be learned again. So they keep on flap between the two interface. So when they're flapping of the interface, switch C or the PCB might not able to receive any information. Okay, it might not able to receive any information because of I do not know where is my source. Okay, it's from port 1 or port 2. It'll be intermediate in this case. All right. So for you to avoid the MAC address flap, you can say that increase the MAC address learning priority of an interface. So I'm going to set this, increase the priorities of this interface to higher than this. So when MAC address is higher than this, it will be override. Okay, so it means that I will keep this as my primary. Whichever I learn from this, I will not accept. I don't accept anything come from 102 when I learn from this higher priority interface. Okay, so you can set the priorities to specifying that which one is one to be preferred to learn from this or prefer from learn from the other one. So it's set to the highest of the priorities. Okay, When let's say they are the same, then they will be just the same. When they are the same, you have to use the prohibit MAC address entry overwriting between interface with the same priorities. Okay, try to not overwrite in each other. I will only learn from the first one. Secondly, I will not learn anymore. Let's say they're going to have same priority of the interface. Okay, there is a two-way of to say that don't overwrite my MAC address entry or set the difference interface priorities to accept which direction that you come from for the MAC informations. Okay, these are the two methods. For the how they detect on the MAC address flap detections, the MAC flapping detection determine where the MAC address flap occur by check whether outbound interface in the MAC address entry change frequently. So they can come in frequently from port this port. Okay, first they learn from this port, then they go for learn another port. So when broadcast happen, they're going to learn back the information by themselves. All right. So that is how they detect. They detect always stuff from the interface, the outbound interface of the MAC address. They keep on changing. In this case, they will find that is have a flapping happen. When this flapping happen, what they're going to alert to you? Always they will alert from the console message. From the console, they will alert to you that, oh, right now I have MAC address flap from this interface and this interface. They have a flapping. So far, okay, for the MAC address flapping in between these two. So for us to prevent, how we're going to anti-flapping to prevent the flapping happen. So configure a MAC address learning priority for an interface. You can set MAC learning priority to 3 on that interface. So the largest in the priority will be the more preferred. Default will be 0. Yeah, default is 0. So when you set one is 3, one is 0. So whichever come from that, I will always accept. Okay. Configure a device to prohibit the MAC address flapping between the interface with the same priorities. Let's say when both are 0 or both are 3, in this case, you can set that undo MAC learning priority 3, allow flapping. So configure a device to prohibit the MAC address flapping between the interface with the same priority of the 3. When they're both having the same priority of 3, I'm going to prevent the flapping in between the two interface, port 1 and port 2. And configure globally MAC address flapping detection. When they detected your outgoing interface are keep on changing frequently, in this case are detected, they have MAC address flapping happen into your environment. And configure the VLAN based MAC address flapping detection. This is do it on the interface itself, on the VLAN itself. Under VLAN 2, loop detect ether loop block time 100 seconds and retrying time 3 seconds. Okay, so they're going to keep on checking. Let's say that you have a flapping. I'm going to stop you, block for how long? For 100 seconds. Later, I'm going to retry one more time. Is it okay so far for this basic method of the address anti-flapping of the MAC address and MAC address information? But for this, actually, it can be avoided. It can be avoided by enable the spanning tree protocol. Let's say a spanning tree protocol is configured pretty well, pretty standard. In this case, this you should be able to avoid by default. But without this, it might have an issue. Let's say you do not configure your spanning tree properly, you might need to have this MAC address configured on the protection of the anti-flapping. So seldom you're going to happen on this MAC address flapping when you define a proper spanning tree. Especially your MSTP or the spanning tree are deal with the other vendors. It's not only proprietary, like not only using Huawei device, you have mixed with the other devices as well. You mix with Cisco, HP, Dell, and this might happen by performing this MAC address flapping. So far, okay? So that is on the MAC address tables entry itself. And for the next one is on the grandidous ARP. This is more into the ARP application. Under the ARP application that we have a lot of ARP. So can you recall any ARP that you know? So like we have a ARP, we have a RARP, we have an inverse ARP, we have reverse ARP, we have grandidous ARP. So they have a lot of different ARP. Even we have ARP proxy as well. So we have different type of ARP. ARP is the main protocols for us to use between the layer 2 and layer 3. Okay, either we get from the layer 3 or we get from the layer 2. So there's between the layer 2 and layer 3 for this ARP protocols. But from this content, they just go concentrate into the grandidous ARP itself only. So what is mean by the grandidous ARP over here? Grandidous ARP actually is just a basic ARP for them to detect, do you have any duplicate of IP addresses or not into your network environment? Okay, do you have any duplication inside your environment? Okay, let's say you have duplicate of IP, they will just give you the alert on this. Grandidous ARP allow a device to send an ARP request message that carry its own IP addresses as the destination IP. Okay, so it means that how they perform from this point. So I make sure that I'm going to send this grandidous ARP continuously to detect in my environment, do I have a same addresses that I've been using? Okay, so when the protocol status of the device it changed to up, so it means that when you set the addresses, when you configure your IP to 10.0.0.0.1, your protocol up. Okay, so normally for our interface, under interface we have a physical and protocols. So when this is up, down, what it means? When physical up, protocol down, means that physically it's up but have no IP configured on the layer 3. That's why the protocol are down. So when this up and this up as well, then they're going to generating this grandidous ARP to check, hey, in this environment, do anyone use the same address as mine? Okay, so I will just doing this way. I will just send, hey, need the MAC address corresponding to 10.0.0.1. I respond this. I send this. Anyone using this? What is the MAC address for 10.0.0.1? Let's say this MAC address that returned back to me is different compared to what I have. It means that they have a loop. They have a duplication. They have conflict of the IP addresses over here. Is that okay? So they reply, hey, I'm using this IP address right now. This is my MAC address. It's just a normal ARP reply. But if this grandidous ARP is a broadcast, I will just send to everybody within my local area network. Everybody will receive, they've detected I have a conflict of IP addresses. Okay, that is the first option of the grandidous ARP to detect a conflict of the IP addresses. Okay, and this one you keep on sending when your conflict is still it keep on happening. So they're going to show under your console. Let's say it's just a window to Windows. They will prompt direct from the they give you a prompt to say that you have a conflict of IP in your network environment. So who to send the ARP? Who are the one who send the grandidous ARP? The one who first generating the IP addresses. When it start to upstate, they will first generating the grandidous ARP to check anyone use a same address as mine. Let's say yes, you reply back to me, then it means that I will have a conflict already. That is the first function to detect conflict of IP. Okay, that's the first one. Secondly, they're going to advertise a new MAC address. Okay, if the MAC address of the device is changed because it's a network adapter replacement, the device send a grandidous ARP packet to notify all the device. So means that when you modify, when you replace your adapters, you change your adapters, After you change the adapter, you connect back, then I will also send one continuous ARP to tell everybody, right now, this ARP has been modified. My MAC address has been modified by using the continuous ARP as well. And the third one, you'll be notify other device of a master backup switch over in a VRRP group. Okay, so in the VRRP group, when you have any switch over, the continuous ARP will be sent to alert all other devices. Right now, we have a switch over from active to backup, from master to a backup. So that is a function of the continuous ARP. They have these three functions. First function is to detect the conflict of IP addresses. Secondly, they will advertise a new MAC address when you have a changes of your network adapters. You replacement your network adapters. And the third is just a notification of the devices. Okay, they were going to have a new notification to alert to you, said that, oh, right now they have a changes. Okay, a changes of the VRP information. Is that okay so far? For this is on the continuous ARP. Okay, continuous ARP. So sorry guys, you give me a 5 minutes. I'm going to do something urgent. I will come back in a while. All right. All right. So I'm back. So for this continuous ARP, they have three to detect conflict IP, advertise new MAC address, as well as do the switching on the VRP group, master and standby. They're going to send this advertisement. Okay, that is on the continuous ARP. So not only this, you also need to grab the idea about what is on the normal ARP, RARP, ARP proxy. So that is the three things also you need to grab the ideas. What are the functionalities of these three? So you need to know pretty well as well. So far, it's all right for this continuous ARP. And the next one we look into is on the spanning tree. Yeah, spanning tree. On this spanning tree, before we go through anything more in depth, we need to just do some review on the STP and ISTP review first. So what are the drawbacks for these two protocols? Why we need to shift away, go for the MSTP? What are the defect? The defect between STP and the ISTP. All right, so let's have a look. First one. The defect of the STP, ISTP. So from here, they said that STP, ISTP both have the same defect. All the VLAN are share the single spanning tree. That is where they are the drawback of the STP and ISTP. And why we need to have MSTP? Because MSTP is for the multi-instance. MSTP is for multi-instance spanning tree protocols. Yeah, that's how they're really able to settle. Certain VLAN is belong to one single spanning tree. They were not sharing the spanning tree protocols. Okay, that is why we need to have MSTP. Okay, as a result, inter-VLAN loop balancing cannot be performed and the block link cannot be transmit any traffic because you're only sharing a single topology. Something like this. Let's say between switch 1, 2, 3, 4, 5, 6, you have a root bridge on the router 6, the switch 6. So in this case, from switch 1, 2, 3, 4, and 5, they need to figure out where's the best path, where's the root port going to the destination. So in this case, this could be the path. Okay, this is a spanning tree they'll form. Yeah, this spanning tree they'll form. And this is a blocking, there is a blocking. Let's say they're blocking interface in between these two. So in this case, that's not been used. So you can see that from here, they have only VLAN 3, VLAN 2, 3, VLAN 2, VLAN 2, 3, VLAN 3. So in this case, for VLAN 3, is go to this way, it's okay. For VLAN 2, go to this way, it's okay as well. But you can see that this is a host, VLAN 2. I have VLAN 2 hosts. So when I have this environment here, the VLAN 2 host cannot talk to another host A to host B cannot communicate because the traffic must be passing through this way based on my spanning tree environment. But from here, it's been blocked already. Blocked by, they only allow on the VLAN 3 itself only. By right, my best way, it should be using this is my best way to reach to the host B. Because of the single spanning tree protocols, I can't control and all the ideal link, this is all the ideal link. This two is ideals. This two is ideals. Ideal link cannot send any information at all because has been blocked by my spanning tree because they only share a single topology. Alright, but this is all depend on how well of your VLAN configuration, and a single spanning tree also can adjust where is your root bridge. Okay. So based on this figure, that's what I explained just now. The spanning tree is marked as the dotted line. Switch 6 is a root bridge, so the rest is a non-root bridge. But because of the VLAN information they allow through the trunk, they have a problem. You can see that from here, for host A to host B, they actually have only one way. This is the only way. They cannot pass through here. They cannot pass through here. So that is the only way they can use for host A to communicate. But your spanning tree to tell that this is a root bridge. So I have no choice in this case. This is where I should perform in this case. But actually it can be solved as well. Let's say you have this situation. What I can do, you can change switch 2 or switch 5, become a root bridge. Then things will be solved in this method. But definitely that is only for cater. You need to check, design properly who you become the root bridge. If you have more able to communicate with each other between the VLAN. Okay. But it's better that perform the MSTP to make sure that everything have their own spanning tree. This path you want to use over here, you can set your own root bridge over here. You do not need to be share a single spanning tree. All right. So for the improvement of the MSTP, okay, MSTP is called the multi-spanning tree protocols. The algorithm that used by MSTP is same as the ISTP. You can say that the algorithm that MSTP is equal to ISTP. Okay, just that MSTP support multi-instant. For the algorithm wise, they are the same. They have no difference between the algorithms. Okay, there are no difference on the algorithms. So it means that MSTP follow the ISTP algorithm to perform the calculation. Just that right now, by using the MSTP, you're able to create multiple root bridge. You can have multiple root bridge on different devices. That is what is highlighted from here. So MSTP is divided a switch network into multiple regions, each of which have a multiple spanning tree that are independent from each other. So it means that even the port is blocking from one spanning tree is not blocked by another spanning tree. Okay, it's a separate. And each spanning tree is called a multiple spanning tree instance, and each region is called multiple spanning tree regions. Okay, MST region. So we have MSTI and MST region. So the MSTI, that can depend on how many regions that you're going to have. So it can be up to 255 regions. 255 instance, sorry, 255 instance. So inside the instance, you make sure that they must have match information inside the instance. Okay, within the same region. Let's say right now I said that switch 1 to switch 6. They belong to the regions HW. That's the region name. Okay, so right now inside this region, inside the regions HW, I create two instances, MSTI1, MSTI2. On the instance number 1, I define this to VLAN 3, VLAN 2. Okay, so the rest, in total VLAN, we have 4094. So they have default MSTI 0. They have VLAN 1, VLAN 4 to 4094. So all other VLAN will be under the instance 0. And that is the default instance 0. Okay, so everything that first join, they belong to the instance 0. Let's say not specify any region. And one more thing, Huawei default spanning tree mode is MSTP. So by default, they already belong to the MSTP already, and they are running on the instance 0. And when you perform this, you can do it like this. I can build two spanning tree. Okay, two spanning tree. One is for instance number 1 for VLAN 3. One is for instance number 2 for VLAN 2. So I said that right now I have a root bridge. This is a root bridge for MSTI1. This is the root bridge for MSTI2. I instance 1 and instance 2. When I'm in the instance 2, so I will have a report. 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 And report. Okay, so the way that I'm going to host A, and this is a path. Okay, so I can design how the path you'll be using. And for the other one, for MSTI1, I have a report here. I have a report here. Okay, I have a report here. It can be this as a report. This is a report. So for host C and host D, and this is where's my path. Okay, so you can adjust multiple spanning tree inside a single region. It depends on how many region, how many instance you require into your environment. Okay, one instance can belong to multiple VLAN. It can be VLAN 3, VLAN to VLAN 5. Okay, so in this case, when you have 3 to 5, this will be changed. This start from 6 to 4094 from MSTI 0. Is okay? So that is on the improvement for the MSTP. What they can solve that STP and ISTP the defect. Okay, because of STP and ISTP only can cater for one single spanning tree, but MSTP is improvement of the multi-instance spanning tree protocols. They can create multiple instances within the same region. Okay, that is called MSTP. How the improvement. Then the next one is on the MSTP fundamentals. MSTP fundamentals. For this MSTP fundamentals, is just give a concept what is inside the MSTP. So inside the MSTP, we have a regions, as I mentioned. They must define which region you belong to, what region name, and inside the region, you must have a MSTI. you have one default as an instance 0. Okay. Default is instance 0. So you can build from 1 to 255 instance. It depends how many instance that you want to build. Okay. VLAN mapping tables. This VLAN mapping table is to tell that which VLAN map to which instance. As I just now I showed, I have an instance 1, instance 2, instance 3. Instance 1 as a VLAN 5 to 10, instance 2 will be 11 to 100, instance 3 is 200. So you can do it like this. You also can set that one VLAN, one instance, but you can only maximum up to 255 instance. So when compared to another type of spanning tree, it called as a VBST. VBST is called VLAN base. VLAN based spanning tree. It means that in this VBST is one VLAN, one spanning tree. But for MSTP, it can be either. It can be one VLAN, one spanning tree, or multiple VLAN within the same spanning tree. So that will be the more flexible compared to the VBST. Okay. So Huawei support 4 types: STP, RSTP, MSTP, and VBST. VBST is not supported into the simulators. So in the exam, they will not test you about the VBST as well. Okay. So that is on the VLAN mapping tables. They need to map between the interface and also the VLAN and also the instance. That's how we call as a VLAN mapping. And next is they have a CST, IST, SST, and the CIST. The CST is called common spanning tree. Okay, we have a common spanning tree. When common spanning tree, it means that you have multiple region, or you have mixed with all those spanning tree or ISTP. Okay, because MSTP is a backward compatible. Okay, then you will form the CST. So like this. So we have a MSTP network, MST1, MST2, MST3, MST4. Okay, you have 4 instances. Whichever is not between the instance, that is called the CST. Okay, the common spanning tree for all your network. So in the CST, it is just something like they're going to be make this entire MST become one boxes, something like this. Okay, they will just show you one box. This is a MST1, MST3, MST2, MST4. Between these 4, they perform the CST. Okay, this is called a common spanning tree protocols. They are calculated together with the STP or ISTP. Let's say the device is not supports MSTP. Then they will form the common spanning tree protocols. And IST. IST is called internal spanning tree. Internal spanning tree is over here. This is IST. 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 And IST. It's within your region, within your MST. We call it as a IST topology. Okay. Then we also have a SST, single spanning tree. Single spanning tree, this one happen into the ISTP or STP. So let's say from here you're connecting a 1 device or 2 device. They're just supporting an STP. That is considered as a SST. Okay, single spanning tree. They're formed between here. Alright. When they are not support the MSTP, then they will run as a single spanning tree on their own. Okay. And the CIST. CIST is called as a common internal spanning tree protocols. The CIST. So within your region, the entire information considered as a common IST. All right, so it means that the entire here. Okay, we have a consider this is a CIST. It's okay. Then we have a regional route, we have a CIST route, we have a master bridge, port role, and port status. Regional route is inside your MSTI. Okay, MSTI. They have every single one have a regional route. CIST route is a CIST, the entire CIST. Within the big pictures, where is my route of this CIST? It means that your common spanning route bridge. Master bridge. Master bridge is happening between this. Okay. Between your common spanning tree, you will define who is the master bridge to the nearest to your CIST route. Port road and the port status. Can you still remember how many port road that we have into the MSTP? The port road and the port status. So can you differentiate on these two? What's the port road and port status? So the port road and port status, they follow the ISTP because they're using the same way to perform the calculation. Algorithm are the same. Port road, we have in total 4 port road. We have a route port, designated port, alternate port, and backup port. Okay, as a port road. On the state, we have 3 state: discard, learning, and forwarding. These are the 3 different port status that we have. So far, okay? The port role, port status, master bridge, CIST route. So you need to know pretty well that how they perform in this case. Maybe I'll just give you an idea here. Okay, so let's say in between this common spanning tree, which one as a route bridge? The CIST route. Let's say this is the CIST route. Okay, in this case, this port it will show you as a master bridge. Okay, based on this, which direction is a master bridge? This also can be a master bridge to the nearest to the CIST. Okay, it will show as a master bridge. Regional route. This device is a regional route. The color one is on the regional route. This is a regional. And within your spanning tree, they will define that is considered as a regional route. Later, I can show you one example on this, how we calculate all this information. So far on the concept under MSTP, I'm sure that on your HCIP already covered some of those on the MSTP. So you should grab some ideas what is on the MSTP already. So how this been done on the calculation. So from it, they will show that on the CIST calculation, what they perform. After compare the BPDU, the switch with the highest priority on the entire network is selected as a CIST route. MSTP calculate as an IST for each MST region, treat each MST region as a single device, and calculate the CST to interconnect the MST region. The CST and IST form a CIST to the entire network. This is what I showed. Within the CIST, I need to get a CIST route. Okay, between the region, I need to form the common spanning tree. Okay, in between. So they consider a single device. A region consider a single device to form the CST calculation. Okay. Hold on. Let me just stop this. All right. So that is on the CIST calculation. They will first calculate the entire. What is my CIST route? After that, CST and also your IST. So for MSTI calculation is in your MST region. MST independent calculate the MSTI for each of the VLAN based on the mapping between the VLAN and MSTI. So this is very important. Let's say you configure wrongly on this, you might have forming different spanning tree already. That's why when I configure the spanning tree, two things need to be matched. Okay. Actually, it have three things, but from here we need to learn about only two: region, the region name, and the VLAN mapping. These are the two steps we need to know. All the switches need to be in the same region. They must having the same VLAN mapping information. They must be the same. Okay. The calculation process is similar to that used by the STP calculated a spanning tree. So do you still remember how the spanning tree calculate a spanning tree? Okay. So how spanning tree perform? They're going to send the BBDU to each other. So inside the BBDU, what's the information inside the BBDU is important. There are 4 information. It's very important for them to compare who become root bridge, who become the designated root port, and also the alternate port. So first, they are compared based on the root BID, a root bridge ID, and followed by root path cost, okay, root path cost, and followed by local BID, and the last one followed by the port ID. So what is inside the BID? For the bridge ID, inside the bridge ID, they have a 2 byte and 6 byte. 2 byte of the priority and 6 byte of the MAC address. Whichever having the smaller priorities is always become the root bridge first. When the priority are the same, then they compare the MAC address. Okay, so the default priorities is 32768 because this is the default priorities. And when you want to modify the priorities, you must perform the step of 4096. There must be a step of 4096. Okay, under the MSTI calculation. Under the MSTP responding to the topology changes. Okay, the topology changes happening, let's say is occur into the MSTP, they're responding similar to the ISTP way. It means that anything changes, the peers, the switches can send the topology change immediate by themselves. They do not have to wait for the root bridge. They can just immediately send the TC topology change to everybody to tell that right now we have a topology changes in our environment by sending the MSTP topology changes, okay, using the ISTP. Okay, so it means that inside the MSTP they're only sending one single BBDU. We call it as a RST BPDU. This is a BPDU they're going to send inside the MST environment. It be same as ISTP. Okay, and for the MSTP to provide the fast conversion, they are using the PA, proposal and agreement. They send proposal agreement to speed up the entire conversion. So it be same as ISTP. Because this PA mechanism is start from who? Start from ISTP. It's ISTP who perform this PA, okay, proposal and agreement. Is that okay? So in this case, we have a designated port root port. So when you're upstream and downstream, they first you will send a proposal so that the port can be rapidly enter to the forwarding state. So they do it under a point-to-point mechanism. Okay, they do it a point-to-point. It's not like a spanning tree. Spanning tree do it all together. That's why they have to wait for the forward delay about 30 seconds. But in the MSTP, they do it point-to-point. After a point-to-point defined already, I back to forward. Then I go for the next point-to-point. So after I go for the next point-to-point. Okay. After I send PNA, it's done. Then I second do the PNA. When done PNA, this is become the forwarding already. I do not have to wait until the rest have been selected. As long as one point has been done, that's it. I'm going to continue with the next point-to-point. Alright, good. They will send proposal, then send an agreement, and return back an agreement to say that, alright, I agree, what is your proposal? So this is I'm the report. You are my root bridge. So this should be the root bridge. Okay, that is how they're going to be negotiated by sending the P&A. So by default, this is how Huawei are performing. Okay. Let's say that to enable the Huawei switches to communicate with the third-party devices that using fast translation in the PA, then you need to use back the ordinary PA. Okay, that is called they're having the enhanced PA into the Huawei environment. So you can switch back to the ordinary PA. So they have two different modes. One is on the speed up, one is on the ordinary way. Okay. And this is how this is being done on the configuration. On the configuration over here, first you have to specify the region name. First, you go to the STP region configuration, set the region name, and instant VLAN 2 to 10, instant VLAN 1120 into instant number 2. And the most important is to active. Yeah, this is important. Active the region's configuration. You must passing through this active the region configuration before for the next configuration. So you must have this done. You need to activate the regional configuration first. All right, and you need to do all these changes to all other switches within the region. So you must doing to all other devices having the same configuration when they are under the same region. They must be the same. So otherwise, that you will not be able to form. They're not able to calculate. For them to calculate the ISTP inside the MSTP, they need to make sure the region name and the VLAN mapping is matched. Otherwise, they can't proceed. Okay. And let's say you want to specify who become the root bridge under this instance. You have to define this. STP instance 1, root primary. STP instance 2, root secondary. Okay. So it means that you go to the switch B to say that I'm the STP instance 2, root primary. For this root primary or root secondary is up to how you define. You can set anytime that you want to. You can set as a primary, you can set as secondary, or you can set at instance 2 priorities 0 or 4096 or 8192. Okay, you can define the different priorities. When you set as a primary, it's always priority of 0. When set as secondary, it's always 4096. That is a value they be applied when you set as a primary or secondary. Okay, that is a priorities. They're the same. So it means that when you set as a primary, it's same as a priority 0. When you set as a secondary, it's equal to the priority of 4096. Okay, and also you can modify the STP path cost standard legacy. So from here, they have 3 types of the path standard: 802.1d.1t and also the legacy. These are the 3 different types of the speed, the path cost standard we can define. So default Huawei are using the 1T, .1T. That is the default way. Let's say you have a multi devices are using different third-party devices, you might need to create the path cost as a standardized. Everybody using a legacy or everybody using .1D or .1T. So that would be very important. Otherwise, different protocol, they might override because of the root path cost. Okay, so set everybody using the same path cost standard. So this is how you modify the path code standard. And the last one is to enable the STP. So by default, already enables. But let's say you just worried, you can using STP enables, and also you can change the mode by STP mode MSTP. You can do this modification to support using the MSTP. Is that okay so far up to this point? All right. So from here, I will just showcase a bit on the MSTP. I will share you the lab right now into the WhatsApp group. So can you start the lab into the, I share into the group. Okay, started ready? Let me start it from my side as well. Is yours started ready? Okay. So from here, I want you want to go into all the just want to show you that what's the difference between these four of them. Display STP brief. I want you to do this. Okay. So you found that after I MSTP configured already, I should have 0, 0, 1, 1, and 2, 2. In total, I will have 3 MST ID. Yeah, 3 MST IDs. So when you check the detail, you can display STP region configuration. So you can see that instant 0 is belong to 21 to 4094. Instant 1 is 1 to 10. Instant 2 is 11 to 20. So that is the VLAN map. And this is a region name. It's called region 1, RG1. Yeah, it's RG1. So switch B, you're having the same configuration, STP region configuration. They belong to the same region configuration, RG1, 21 to 4094, 1 to 10, 11 to 20. It's instant 1 and instant 2. All right. So I want to check the detailed information, display STP. Okay, display STP. So from here, you found that who is the CIST bridge. Okay, CIST bridge, and also your root, regional root, root port ID. So that is the information they'll be showing from here. The 0 behind here is the root path cost, because myself as a root bridge, CIST bridge is myself. Yeah, CIST bridge is myself. Yeah, switch B, display STP. Yeah, there's the same information, 1254 60 CD. Okay, 60 CD. Switch C, display STP, 60 CD. So you can see that the CIST bridge, it means that it's yourself. This is your local bridge ID, the root and the regional root. Okay, is 6D CD. It means it's a switch A. So this whatever is shown from here is belong to the instant 0. Instant 0. You also can check like this. Display STP instant 1. Okay, this is my instant number 1. Okay, instant 1 global info. Sorry, global info. So my MSTI bridge ID is 4670. MSTI region root myself under this region under MSTI 0 4C1F CC3E 60CD. Okay, and from this I show you on the instant number 2. Under instant number 2, the root, the regional root is 1254. It's a switch B. It's not belong to myself. Okay. So let me check from here again. Switch 1. This is on the CISTB. C60 CD. Instant 2. That is what am I? Then this is the root bridge. Okay, the root bridge. 0 is a root bridge. Okay, this myself as a primary root. So from here, I would just want to showcase a bit on how this MSTI work in between all the switches. So I'll just more to showcase. Let's say right now I do this. I do system undo STP region configuration. I remove the region configuration on the switch number A. Okay, done. Remove already. Display STP. Okay, display STP brief. So under my brief configuration over here, I only have 0, 0. I do not have instant 1, I don't have instant 2, I do not have instant 3, and so on. But for switch B, you still have this display STP brief. I only have a 0, 0, 1122 is still the same. So it means that switch A is running as a STP. The rest is running on the MSTP. So let's say I change from here. System STP mut RSTP. So what's the difference from here? Display MP STP bridge. So right now they're doing calculation, discarding. Should be very fast. Okay. They're doing the proposal agreement from the port number 2. Discarding. Learning, then they'll go up to the forwarding soon. So by right, they should be pretty fast. When they have a compatibility and for MSTP to ISTP, they will just use back the STP, spanning tree protocols. So it's forward right now. Okay, forward to forward. Should be C. So you can see that on the switch C, you found they have one master and one master. This is a master bridge. This is a master bridge to tell that from port number 1 is a master bridge. Because they are not under the same region that we are, RG. Yeah, that's why in this case, they will see the master bridge over here. So when everybody is inside the same region, then I will not see the master bridge. Master bridge is only between region to another region. They tell you that this is the best way to the next region, to this region, okay, to the next spanning tree protocols. They have a master bridge. Let's say I configure back the configuration on the switch A. So remember, configuration need to be identical. Right now, I do it on the switch number A. I said that STP mode MSTP. I change back to the MSTP mode first and go to the STP regions configuration. And I said that regions name must match RG1. Okay, set as RG1 and instant 1 VLAN from VLAN 1 to 10. Instant 2, sorry, VLAN 11 to 20. So that is on the instant. But the most important, if you're on the last step, you need to active regions configuration. Okay, you must have applied this, otherwise this is not been running. You need to activate your region configuration, display regions STP regions configuration. Okay, so make sure this information is matched the rest. Okay, and go back to switch C. Just now we have a master port, right? And now I should not see master port because they are belong to the same region already. You back to the root. They belong to the root port already. It's no longer up to the master port. Okay, that's master port. Master port. Is that okay? The master and the region are different. Is that okay? Can you differentiate on these two? What's the difference between the master bridge and the root bridge, the root port? Master bridge is to tell you that when you have master bridge, it means that you're connecting to the different region already. You are not within the same region. From one region to another region, you should see the master bridge ID. Okay, this is master bridge. The role for the master bridge. So for MSTP, they will add on this master bridge role. Not only there's a root port, designated port, alternate port, backup port, there's one more role as a master bridge role. That is one more that I need to be highlighted from here. Is that okay? Any questions? So let's say they have no any question, then I will just continue with the next topic. All right, I will just stop this. Let's say you have any question, you just drop your question into the group, okay, into the WhatsApp group. So the next one is on the iStack. iStacking. How are you going to perform the iStack? iStack is actually just like you're going to combine multiple physical switches to become one single logical devices. That is called the iStacking. So under the typical campus networking, this is how it look like. Under the core layers, they are going to perform the CSS. Okay, CSS. But under the bottom layers like this, layer 2 access layer, they're using the iStacking. So as I mentioned, iStacking is meant for the box switches, and for the CSS is more for the chassis switches. Okay, why we need to do this? So always in the typical campus network, we're going to have a CSS, Ether trunk, and iStack to provide a more redundancy and to provide the load balancing of your layer 2 and layer 3 traffic. Because into the layer 2 environment, when you have a switches connect to another switches, with a redundant connection, what will happen? Spanning tree, you come in, one port you'll be blocking. You only can have one active lane you'll be using only. Okay, so by using the either trunk or the iStacking, I do not need to have all this worry about the spanning tree, because when they're already stacked, they are considered a single device already. They not belong to two devices anymore. Even though when I can also perform the either trunk on the port channels among the two physical devices. So see that in total over here, there are 4 devices. By right, I have like this: switch 1, switch 2, switch 3, and switch 4. So the connection I connect between these two, I will doing this for redundancy purpose. I will doing this as a redundancy purpose. But based on this environment, this cannot be done. Because for the either trunk, they must be bundled when you connected to the same device. Let's say you connected to the different device, then you might need to use the E-trunk. You need to maintain another E-trunk. It will be also pretty complicated. So that's why over here, what we're going to suggest, we're going to say that, hey, why don't you just over here is using the CSS. And below here, you're also using it as a iStack. When one is iStack, one is CSS, that is okay, because they consider one single logical. In this, you become like this. This is a switch 1 and 2. This is a 3 and 4. They were just doing like this bundling. So this one, in this case, you will reduce a lot of your connections, and do not need to worry or maintain the redundant connection, and do not need to maintain the spanning tree anymore, because everything I will be one single logical already. When your physical go down, it not affect my logical interface. Okay, so this one is provide the simplicity to simplify the entire environment. Okay, the device at the all layers use the stack technology. There are few logical devices in this case. So when this, it be just combined to become the topology, something like this. So after you have the CSS, so I have one core switches connect to 2 aggregate switches and connect to the 4 aggregate switches. So this is how they're going to simplify the topology. So this is my core, my aggregate, and this is my access. Okay, so this is how they are going to be make it as a logical topology. Okay, there's no loop at the layer 2. Yeah, because they are considered one device, and therefore no spanning tree protocol is required. Other it's STP, ISP, MSP is not required in this network, because everything is just a one. Consider one device, one link. Okay, one device, one link, one device, one link, one device, one link. They have no interconnected, so everything is just a point to point. When point to point environment, they have no looping already. Okay, that is on the simplicity. Next is more efficient. For efficient, Ether trunk is used to between the device and the different layers. For this is to provide the loop balancing traffic as well as improve the link resource utilization. Okay, that is on the efficiency. And the last one is on the reliable. Reliable means that I can have a fault, a failure of the device, a failure of the link, a failure of the aggregation, a failure of the link. So anything you can have a failures. I have a fully redundancy of every single link and also device that I have. But what is the disadvantage by using this environment? They have a high requirement on device performance. If a large number of fixed configuration switches are stacked, the performance of the master switch control board may deteriorate. You may degrade. Okay. If the service port are used for the stacking or the CSS, service port resources are occupied. So for the iStack, it can be depend on how many stack devices you can be combined together. So based on Huawei devices, they can be based on 8 or 16. 8 switches combined as one stack, or 16 switches combined as one stack. But based on Huawei recommendation, they recommend only 4 in a stack. Okay? 4 switches in a stack, you'll be able to get the full utilization and get the full performance to these 4 devices. Because you need to remember, when all they combine, only one device are handling the traffic, and that device must be very powerful. That's why we try to not aggregate that many of devices into one single stack. Okay, we try to make it 4 as a maximum in a stack. Okay, 4 maximum in a stack. Because of the control plane is only one of the boxes. And another disadvantage is when they are using iStack, they can be have 2 way. Using the service interface to perform the stacking, or using the stack cables, a dedicated port, dedicated stack card for them to perform the stack, or you can use a service interface. Okay, let's say using service interface, it means that some of the interface will be occupied by the stack. You cannot fully utilize all the interface already, because some of the interface will be allocated by the iStacking function. Okay, that is on the typical campus network, the advantage and also the disadvantage. The disadvantage actually is not that it can be controlled. Okay, it can be still controlled. Like the number of the switch in the stack, you can control every single stack in 4 or maximum up to 5. But recommended is still between 4. It will be the best. You get the best performance. So under the iStack fundamentals, so over here we show you that what are the function for fundamentals or the principle using on the iStacking. So the first, the device stacking, iStack. So it's called as an intelligent stack. This one is only meant for the box switches. So it enables the multiple switches to become one single logical. So when we have this, let's say right now I have 4 of them. So in this case, I require using each of the boxes require F2 port. So I will do it like this. Interconnect, and top to bottom. So I form as a ring. There is a ring. So instead of any stack cable is go down, I still can be forming by using another way. So this is on the iStacking. iStacking for this can be a service interface or stack interface. So they have 2 options for us to perform the iStack. You can using a service interface or using the stack interface. That is on the 2. So in this figure, you see that after I have a stack link in between, they consider is only a point to point. And this is a redundant link between you perform the either trunk. Okay? Switch A, B can form a stack and they consider as one stack. So it's a point to another point. So in between, let's say do not want to using spanning tree, you can just form as a either trunk. So inside the iStack, you should have a master. The master is the one who control all the information. Okay, this is where we go into check on the iStack concept, the concept of the basic in the iStacking, the row, the stack ID, and the stack priorities. Under the row, they have a master, standby, and a slave. So it depends on how many devices that you have. So again, let's say you have 4 of them. Yeah, let's have this. So in this case, normally the first one who started, you be the master. That's the first one who started. Whoever who joined, the second who joined as a standby. And the last join is all the slave. Okay, normally this is the one. Standby is always backup of the master. Then slave is just slave. They're just forwarding the traffic. Just follow the master. They do not do anything. Okay, a master switch manages the entire stack. A stack has only can be one master switch. A standby switch acts as a backup of the master switch. If the master go down, standby will take over all the service from the master switch, and they will elect another standby. A stack has only one standby. And the last one, slave. A slave is just forwarding service traffic. A high number of slave switch can be increased the forwarding performance of the stack. Because every time you forward, you need to get from the master. Master to say that, oh, you can send out from there, you send out. Okay, that's why when you have a lot of amount of the slave, it will increase the performance of the forwarding. So that's why I said that maximum up to 4 of them. Okay, apart from the master and the standby switches, all other member will be the slave. So like this is what I show over here. One master, one standby, and the rest is all the slave. It's a slave switches. And next we have a stack IDs. A stack ID identifies a stack member of the slot ID of the members. Each stack member must have a unique stack ID and the stack. Okay, this one, let's say it's not defined, they will just follow the sequence from 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say you define yourself, you can set it before you join to the group. So it means that you need to preset everything first. Let's say I want to make it there as a master, you also can set the priority first of the master before you start them up or before you join them up. So it means that you already can do this. Okay. You can set that on, this is on the stack ID. 0, 1, 2, 3. So you can configure before they stack. So you need to start up the device, do the pre-configuration first, set this is on the stack number 0, stack number 1, stack number 2, stack number 3, as well as can set the priority as well. Let's say I want to be a master, then you will start to power on. Power on, connect. Power on, connect. Power on, connect, and connect. Like this. So this is how the way that we are going to add this information into the group, into the stack. Alright, that is how they perform. Always put up, do all the changes first, shut down, add to the stack, power up, add to the stack, power up, add to the stack, power up. When add the stack already, they start to, when they're first starting, they're going to process of the starting, of the stacking. They start on the, when they're going to starting the device, they will check, do you belong to any stack or not? Let's say you belong to a stack, I need to grab the information from the master switches. I need to get all the configuration from the master switches. Alright. So that is on the priorities or the stack ID we can set. How the stack ID represent into the iStack? So on the normally for the normal switches, let's say for the 8-port switches, okay, the first port always showing like this: gigabit 001 up to 0048. This is how it look like. Okay, when you join into the stack already, the first number over here is considered the stack ID. Okay, the stack IDs they will show based on the ID 0, 1, 2, 3 that you set. So let's say you belong to the stack number 1, you get the GI 101 up to 1024. Let's say you get number 2, you get a GI 201 up to 2048, something like this. Okay. So the first digit is considered as a slot ID. This slot ID you're going to define as a stack ID in the configuration. So you need to pre-define first. Otherwise, they're going to select themselves. Okay. Let's say you want to be precise using the correct stack IDs, you need to pre-configure before you boot up the stack. And next is on the stack priorities. A stack priority determines the role of the stack member in the role election. A higher priority value of the stack member increases the probabilities of it being elected the stack master. Okay. So they're going to doing the election. This election only happened when they first started up. When they first started up, they were going to do this election. After that, no. Only until the master go down, standby take over, then the slave, you're going to do another round of the election, and to tell that who are the standby. That is how the process has been done. Okay. All right. Next is on the set up a stack. Okay, set up a stack. For us to set up a stack, first we need to enable the stack function and set the stack parameters. So this is all depend on whether you are using the service interface or the stack interface. Okay, so they have two options on the parameters that we define. Let's say you're going to use a service interface, you need to create a logical stack port. Okay, create a logical stack port to tell that right now I convert my service interface to become the stack port. So this one later we're going to go more in depth on how we define on the logical stack port. Okay, stack interface will be pretty straightforward. Then in this case, you have nothing to define. You just have to define like the priority, the stack ID. So let's say you're only using the stack interface. But if you're using the service interface, you have one more step extra. You need to change from your physical interface, the service interface, to become a stack port. That is what you need to define. Okay, after you've done all the changes, power off all devices. Connect the stack cables, power on all the devices, and the system automatically complete the stack by themselves during the election. Okay, so the best if we just do it one by one, add it in one by one. Or let's say it's okay, you can do it at the same times. Okay, 3 at the same time. Connect everything, power on at the same time. But no difference when you add one by one. Just that the time you take will be a bit longer because they need to process one by one. Okay, and let's say when you put out at the same time, they just do it at one time. You do not need to wait for the time for every single switch to perform. They do it at the same time. Let's say you add one at a time, then you just accumulate the delay. Okay, that is the only thing. So it depends on which way they're using. Can be start everything together or start one by one. Okay. So that is how the performer, when they complete all the changes, on the master switch election, how they're going to go through this. First, they will compare the switch running status. The switch that has been running is preferentially elected as a master switch over the switch that is starting. So it means that I can say that the first one who starting, you always be the master. All right. If multiple switches complete the startup at the same time, let's say everybody start at the same time, then they compare the stack priorities. When the stack priority are the same, then they will select based on the smaller MAC address. Okay. So normally what we do, we set the priority, and also we start the master first. Then the standby and slave, we do it together later part. Okay. That is how the step that we perform to set up a stack. That is a sequence. Whoever first started complete already, then they will become the master. Let's say they start at the same time, they compare the priorities. The higher the value, you be the master. When the priorities are the same, they select the smaller MAC address. The smaller the MAC address become the master switches. So far, okay? So after the master is been elected already, you will collect the topology information from each of the member switches and calculate the forwarding entry and to be blocked interface. Because as I mentioned, there must be a ring. So I need to specify which traffic you will not going across. Let's say going across, there might be looping and looping and looping already. So there need to be one port has been blocking interface. Before, let's say, if anything go wrong, this will become the active. Okay. So far, okay. For to start up, setting up a stack. Okay, this one is pretty straightforward. On the stack mode, this one I mentioned, they have two different stack mode. Switch can set up a stack using the stack card or the service port. A stack card can be used in the either of the forwarding mode. Stack card are used to connect switch through the stack cables. Stack cards are integrated into the rear panel of the switches, and the switches are connected using the integrated stack port and the stack cables. Yeah, so that is using dedicated stack port. Okay, this one using the service interface. Okay, when service port are used is to set up the stack. The stack card are not required. The service port. Okay, sorry, my mistake. This one also using a stack port. Okay, using a stack port. Okay, just that you need to have one is integrated, one is on the dedicated stack modules. You need to purchase the stack modules for you to perform the stack. Okay, one is just using a stack card through the stack cable. The other one is using the integrated stack port. They have a dedicated port behind, it really hard-coded, that is on the stack connection between the switches. And the next mode is on the service port. Service port are used to set up the stack. Stack card is not required, but the service port are physical port that configure a stack member into the bundles. So you need to define into the logical stack. So you need to define a stack port, number 1 and number 2. Because we need to do a ring. So the stack port, number 1, number 2, like this. Get 1 to 2, then another port 1 and port 2. 1 to 2 and 1 to 2, like this. So they need to do a ring. Let's say they have 3 devices, more than 3 devices. You need to create 2 port. Okay, 2 port. Port 1 and port 2. In total can be up to 4. Okay, but let's say using all the 4 port, then it depends because of in the normal switches, we using the uplink port. Okay, there's an uplink port to become stack port. Let's say you fully utilize all the 4 port. In this case, you're going to reduce your uplink connection already. Okay, you occupy your speed already. You can bundle 2 physical and 1 port. Okay, port 1, 2 physical, port 2. So this one, you increase the bundling between the stack. Because let's say this is only 1 gig, in total you have 2 gig of the stack cables. Okay, stack link. Let's say if a 10 gig, you have 20 gig of stack cables. So it depend on the how well of redundancy you required. Normally, 2 port is good enough already. Let's say your uplink is 10 G port. Let's say it's 1 G port, then in this case you might need to have 2 of them. 2. Okay, 2 for one port, another 2 for the other port. As become a logical stack port. Okay. A logical stack port is exclusively used for the stacking and has the physical port is bundled. Each member switch in the stack support 2 stack port, and the stack port is be n divided by 1 and the n divided by 2. Whereas the stack port ID is a member switch. So there can be have 4 port, but you can be only have logicals. The logicals port only 2. Port 1 and port 2. Okay. But within the port 1, it can be bundle multiples. Bundle multiple physical inside. Okay. So on here, you can use the ordinary cable connection or using the dedicated cable connection to perform the stacking. Alright. So you can see that 2 of them can belong to the one stack, or 4 of them belong to one stack. So it depends on how you generating the connection. Is that okay? Did I answer your questions?
Yes, I asked you about the stack port. If we have only 2 member switches, so active and backup, master and backup only.
Yes.
Should we can we set up the stack port on number 1 to on switch 1 goes to number 1 to switch 2? Can it be set up like that or not?
So what you means that, let's say I have like this, only 2 switches. Am I right?
Yeah, only 2 switches.
So you have like this.
Yes.
Okay, that is let's say this is a master, and that is a standby.
Yeah.
So in this case, what we're going to do will be just like this: 1 to 2, 2 to 1.
Oh, there is no straight port 1 to 1.
You can also perform 1 to 1.
Oh, also.
Also, because when you only 2 switches, you can do it on the same sequence: 1 to 1, 2 to 2. Yes.
Okay. Thank you.
All right. I don't know. Yes.
This is using service port surface, not stacking port.
No, using stacking port, using the physical service interface.
Service interface.
Yes.
Is physical stacking port must crossing.
Yes.
Oh.
Stacking port might be crossing, but using service interface, it can be straight or crossing.
Okay. Thank you.
Okay.
Oh, maximum long cable of VC cable. For stacking cable. I mean.
For the it means for the cable itself, for the stack cables.
Yes, for stack cable is maximum length is
for you no, they have 2 different length that can be 3 meter, can be 5 meters.
Oh, 3 meter or 5 meter.
Yes.
Okay.
Yes. And for the service interface, actually it depends. It can be very far away as well. It just be based on what is your SFP you are using. Because let's say using service interface just like ordinary port, using just a normal optical fibers, you can be up to 10 kilometers away as well.
Okay.
Okay.
Get it.
It just depends on distance that you use on you can even up to 50 meters, let's say you want. But for the dedicated stack cables, then they have 2 choice, 3 or 5 meters.
Okay, get it. Yeah.
Okay. Thank you. So for the priority of the slave switches, as long as you will not set higher than the primary, the master, you're fine. So let's say you set on the primary, the master is 100, the standby you set as a 50, the rest is not setting. Then in this case, you have 1 master and 1 standby already. So this is how we can define based on the priorities. Okay. So for us to add a switch to a stack, so let's say right now I have running the stack already. Switch A, switch B, switch C. I have a master, standby, and the slave already been running. Suddenly, I will add the switch D inside the stack. a stack running normally enable a stack function on the switch D, power off, connect to the stack and power on. The system automatically complete the stack and the switch D become a slave switches. This switch D will never become the master or standby. They always be the slave after already stabilized. Okay. So if the port using as a service port as a stacking, the physical port of the newly added switch must be added to the logic port as well. So it means that you need to specify on this port and this port to define as a, this is logical, this also need to be logical port for them to form the peers, okay, for them to form peers. And they're going to negotiate what type of the ID you should use, what the stack ID you should use. Then they compare. When member join, they will just get the information from the master and continue. So after the switch connected is switched on, they will elect it as a slave switches. Regardless of any things that you have, the role of other member switch in the stack is remain unchanged. They will not do any changes. Okay, after the master is there, standby is there. When whoever join in is always as the slave. And the master switch update the stack topology information and sync the stack topology information to all the members to tell that right now we have one more member join in. I assign the stack ID to the new member switches. I will just add, let's say you did not define your stack ID, I will assign you a numbers for the stack IDs. Let's say you not configured yourself. If you not configured, I will give you a numbers. Or your ID is configured with others, I will also give you IDs. Okay. Let's say over here, this is a 0, this is a 1, and this is a 2. When you come in, you have a 1. So when you join already, the master you're going to tell you that, hey, you cannot use 1 because 1 has been used by standby switches already. You have to use 3. So I'm going to change, I give you assign the stack ID to you. Let's say at the beginning, you already set yourself as 3. Then it's okay. So it just continue. So I do not need to send you to tell that you need to change your stack IDs. All right. When the updated the stack ID and the sync or the configuration file, then everything will be run as a stables. That is a process how we add a switch into the stack. Okay. When the power off and power on the switch they added into the stack. Is it okay so far? For the stacking, adding a switch into the stack. For the next one is on the merge the stack. For the merging of stack, I will cover after our lunch. Right now it's about 12:30. Okay, 12:30. Let us to take a lunch and come back. We continue with this LAN technology with the iStacking and the CSS. As well as later part we need to cover on the Ether trunk as well. Okay, let's go for our lunch. And one more reminders, whoever who join the training, please rename yourself. Please rename yourself using your name and your company. Is Alex here? Alex, can you change your rename yourself and also Fino? Can you just add your company behind your name as well? And Zigit. Oh, they have two accessing. Okay. So make sure your name and your company is together. Please rename it. And now we are going to take our lunch break from 12:30 to 1:30. So we have 1 hour of our lunch break. Okay, so enjoy your lunch. I will see all of you back on 1:30. All right, thank you.
Thank you.
Thank you.